Hello. Today we're going to look at how to optimize text generation inference in terms of how to deliver the maximum efficiency to your product using TGI on a given model. The first thing to have in clear is that there is no one speed. You might even care about different things depending on who you are and who are your users. This image kind of conveys very well something very important is that there are two aspects, throughput and latency. They are very different measures. They're not the same axis. They are orthogonal to each other. And depending on your use case, you might care about one versus the other. Just to get the idea in mind, latency is the length of a pipe. Imagine you have a flow of water in a pipe. It's how long does it take for a single drop of water to come from the start of the pipe to the end of the pipe. This, as a droplet of water, this is what, as a user, usually you care. It's like how long do I wait to get my feedback? Throughput is the width of the pipe. It's how many droplets can go at the same time on the same pipe. The two numbers are very different, should always be clearly made different, even though a lot of benchmarks don't split them enough. This is a very important picture, and I'm going to come back to it. So let's go into TGI. So text generation inference can run any machine learning model for LLMs. And let's try to start Zephyr B beta. It is Hugging Face latest model fine-tune of Mistral, and currently it seems to be working pretty great. I want to update my product with it. Let's see how it does. So I'm going to start by launching it. I'm running on 4810Gs here, just showing it here so there's no question. So I have a 4810G box. This is for the demonstration purposes. And I want to know on what kind of device should I use. Should I use A100s, A10Gs, B100s? I don't know. So I'm going to start with that box for the show, for the demonstration. So I started Zephyr. It's now loaded and connected. We can check it out. So it works perfectly fine. There's an answer. What else is correct? In text generation inference, we have a tool called text generation benchmark. Which requires a tokenizer name, which is just the tokenizer of the model, so it makes sure that it sends a proper amount of tokens. And let's launch it up. So you're going to see a lot of measures, bar charts everywhere. The main goal of this is to provide you with a curve that's going to look at the latency versus throughput, both of them at the same time. On the left-hand side, you have what we call prefill. This is when the first request is received by text generation inference. So usually long queries, conversations, so on. And on the right-hand side, you have the decode, which is every new token. For those, usually, most of the time is usually spent on the decode part. And for those, we have what's called the KV cache, which allows for it to be faster than this. So usually we don't look too much at this. But you might want to, if you, for instance, know that your users are sending very long prompts, maybe that's interesting to start looking at. Usually, though, as I mentioned, we kind of look mostly at this. So let's see. We have a bunch of numbers here. The main one we're always looking at is this decode token latency thing. So here it's 36 milliseconds per token. That means every single token that's going to be generated is going to take 36 milliseconds to generate for everyone. On this particular screen, we're looking at the batch size, which means 30 users have been sent a single token in 36 milliseconds. If I look at other tabs, you see if there's less users, it's only 32, it's faster. But the main thing is it's hard to read those numbers individually. What we want is the lowest possible latency for a single user, but we don't want to increase too much when we add more people, more users. So as you can see, this is pretty much a very vertical curve, which means this is throughput, this is latency. When we increase the throughput, the latency doesn't change. That's very good. That means you can have many users in the same system and it's not going to show anything. Yet I want to see how far we can go with this latency, because here we don't see the throughput curving out. And you see when you reach a certain point, it's going to start curving out. So let me do this. Yep, batch size, let's do 32, 64, I need to do it that way. 64, 128. So I removed the first steps because I don't care. Okay, and you see it starts curving out slightly. 45 milliseconds, you see we're increasing. There we go. So we start to see the curve there. So it started there and then continues there. And basically it's going to end up being very flat, like this one. Like very flat. The throughput gains marginal gains, and the latency kind of get a big hit from adding more people. What does that mean? This means that every single user is going to be here like pretty much 50% slower. Okay, you have twice the amount of people, but everyone is going to feel your system is getting slower and slower. And for this part, it's even worse. And at some point, it's going to be basically everyone is going to be slower, and you're not going to pass any more people on the same machine. Therefore, what you want to do is cut it off somewhere around the inflection point, and depending on who you are, what throughput you can allow, and what slowness you can allow, you may change. That's why we have this tool. We want to really look at the curve, the entire curve, and determine where to stop. So for this particular case, this is 1/8 ng I'm using. I probably want to stop before that. So let's say I'm going to stop at batch size 64. That means I'm going to allow maximum 64 concurrent users using the flags. And I know no one is going to see any more latency than 39 for 40 milliseconds. And at that point, I'm going to have, basically 2000 tokens per second throughput. If that fits my use case and I don't know I'm not going to have more usage, that's perfectly fine. If I want to push the throughput and I'm okay with the latency, I can do that if I have a lot of batch jobs. But if I'm running a chat app that people interact with on a daily basis, I probably want to stop at some point on the latency side. So this is what I would choose for this particular choice of hardware. But I'm on a 4/8N box, so maybe I want to use more GPUs. Should I use 2 GPUs in charging, 4 GPUs in charging? Should I use an 100? This is what I'm going to try it out. So I just launch with another setting. This is where you should interact a lot with your system and try a lot of different settings before making a decision. So here I'm launching on the 4 GPUs that are going to interact. They're going to have the same model, and they're going to share their compute cost among all the all the shards. I'm going to put back the other tests, so batch size 1, 4, 8, 16. Oops. Okay, I need to put it in full. Okay, let's them in order. Try to do this instead. Okay, so now we're running on the 4 GPUs. And you see, first of all, that the base latency, let me go back to the batch one, dropped. It was 32, and now it's 20 milliseconds. We're going 50% faster, or whatever, but it goes much faster. This is really good. That means your users are going to see a lot the faster text being printed out. So really good property. And you see the curve kind of stays the same too. It really goes pretty much flat line. It has pretty much the same curve, except we had the inflection point at 2000. Maybe it's the same. What happens is we have more compute, more GPUs, but there is still some synchronization. All the GPUs need to talk to each other. Therefore, at some point, it might limit the throughput despite you having more compute. And this is probably what happens here. So I can pump up a little more the throughput because, as you can see, on batch size 64, now we only have 30 milliseconds. So it's still much slower than 20, but it's much faster than when we had on a single box. But if I want to maximize a lot of throughput, maybe I should have one model on each GPU and just split the load across them. I should probably get more throughput with that, but slower latency. And then you can start with only 2 shards. Because what's probably going to happen here, if we wanted to deploy at Hugging Face, is this number is much better than the 32. And depending on what is the backend use case, we might be very fine with 2000 tokens per second throughput. It's going to be much more than what we expect. Therefore, I'm okay with having two cards instead of one, just to get the snappy response times. Okay, we're done. Let's try again. We still have 20 milliseconds, which means only having 2 ATNGs is pretty much getting what we need, which is the fast decoding step. And you see it started curving out a bit faster than before. Therefore, the bandwidth in the network dimension between GPUs is definitely coming into play. And so here to get 2000, we are at batch size 64 pretty much. So for a cost reason, maybe I don't want to use 4. I'm going to use only 2. And again, 2 deployments on 2 times 2 is going to be my sweet spot for my particular application, where I know I'm not going to go above that. This is a very interactive tool, very important, and that we use all the time to know what kind of hardware should we use. And we have to know a little bit about what we expect in terms of load. But yeah, this is really important. And this is how we do it at Hugging Face, to deploy TGI on the best possible hardware to minimize the cost, maximize throughput, and have the best latency possible. So you need to look at the whole curve. This is why benchmarks usually are a bit lying, depends where they are and where they sit on the curve. And your use case, you might care more about this than this. It really depends, and no one can tell you beforehand. You need to look at the whole curve. Small addendum. I mentioned the shards as one flag to get the best hardware for the possible model. There are other flags we usually keep in mind, especially for the cost side, which are other implications, which are perplexity. There's a quantization flag where a lot of models have AWQ models, GPQ models, which are 4 bits, which are much smaller in terms of memory. They can fit much smaller GPUs. And therefore, we also try them out very regularly. They all have different implications. I encourage you to read it out. Some can work on any model, some require a dedicated model, some are faster than others, some have lower, poorer quality drop. I mean, the model gets a bit not as good as the original model. So this is something we also look at very much in terms of optimizing our workloads. And I encourage you to launch the -- help to see all the flags. There's a lot of flags, and some of them also enable you to choose a bit better how to deploy. So the idea is start it up, look at the benchmark, change a few numbers, look at the benchmark again, and do that over until you get something satisfying. No need to overthink it or to go too deeply into it. It's a benchmark. It never will reflect the exact situation in production. For production, we actually use the telemetry to see how it's performing and is it living up to what the benchmark said. So this will only get you so far, but this is the best start and this is the easiest to play with, to just launch whatever configuration, try something else, and you can choose, for instance, I want longer context, launch up a rope scaling and actually send very long text and see how it performs. Thank you.